Hi everybody, good morning to everyone. Today I'm going to present on binary codes. First of all, introduce myself. I am Nandini from SRIT College, CSC department. Today I'm going to present a binary code which is an important topic in digital logic and computer organization, shortcutly known as DLCO. In this topic, I will explain the types of binary codes, their examples, applications, and importance in digital systems. So, in this topic, we are to explain these are the so, basic concept of introduction of the binary codes. Binary codes use it to represent different types of information in digital systems. 0 represents low and high, and 1 represents high and on. This makes information easy to electronic circuit to process. There are fundamental digital electronics and computer systems in CPU. So this is the basic concept and introduction of the binary codes. Next. Types in binary codes, there are two types: weighted codes and non-weighted codes. Weighted code means each bit position has a fixed weight. Non-weighted means do not have a fixed positional weights, they have to change anyway. So this is the difference between the weighted codes and non-weighted codes. Weighted codes in this divided 8421 BCD binary code. It is known as weighted codes, and gray code and hexed codes as a non-weighted codes. Different codes are designed in different digital computers. So these are the different types of binary codes. Next, 8421 BCD. BCD is known as binary coded decimal. So shortcutly we have to call BCD, and full name is binary coded decimal. BCD is a weighted code. It is a binary decimal which each decimal represents by 4 bits. The weight of the 4 bits is 8, 4, 2 and 1. For example, decimal we have to take 5. It is represent as 0, 1, 0. Why it called means 4 plus 1 is equals to 4, 5. So this is the basic concept and easy example. So these are the binary code decimal. Next, gray code. Gray code is non-weighted code, and it is also similar to a binary code in which only one bit change at a time. Only one bit change at a time between two consecutive codes. It helps to reduce errors during transition between values. It is commonly used in rotatory numbers and digital systems. It is also called as a reflector left to code, used in systems like rotatory encoders, ADC, and Curremax. In this table, we have decimal and binary and gray code. See, we have to take example 2. In binary, 8421 means, so 2 is known as we have to take 1, 0, 0, 1, 0. In gray code, they had changed 0, double 1. So this is the difference between the gray code and binary code. Next, XS3 code. XS3 code is also under a non-weighted code. To obtain, we add 3 to each decimal digit and convert the result into binary. For example, we take 5. 5 plus 3 is equals to 8. So XS3 code is 5. So is 1000. So in this table we see decimals and decimal plus 3 and XS3 code. We have to take any decimal, and we have to plus add 3, and we have to access 3 code on automatically. This is the known as XS3 code. And last, American Standard Code for Information Interchange, shortcutly known as ASCII code. So it is used to represent characters, and each character is assigned a numerical value that can be represented in binary. It is widely used in computers and communication systems. It is used to represent the letter numbers and special characters only, and it uses say 7 bits, 128 characters, or 8 bits, 256 characters. So they have some difference. It includes letters also, digits also, symbols also, and control characters, strings, cues. So that is the control characters. So in this table we see characters and decimals and binary in 7 bits, 7 bits or 8 bits as our wish. So this is the known as ASCII code. So these are the basic divided into weighted and non-weighted binary codes, and these are the codes how we explain how it works. And last, applications of binary codes. Applications of binary codes are used in computers, digital storage and digital displays in 7 segments, and encrypt data security, communication systems. Binary codes are also used in displays, encoders or decoders. Almost every digital device uses binary information Totally. Digital communications, microprocessors are controlled. So these are the applications of binary codes. Next, advantages. Advantages means can represents numbers, characters, and other data. Efficient for data storage and transmission. Simple and easy to implement in digital circuit. They make information easy to store and process and transmit automatically and shortcutly we have to understand. So this is the advantage of the binary code, and they form the basic information of modern digital computers. So we have to logical and shortcutly known what is the concept and what is the known as of the binary code. So this is the advantage. In our daily life also we travel in binary codes like mobile phones, cameras, musics and video, cars, ATMs. These are the daily life we have to use, mobile phones always using. So these are the binary codes in everyday life we never use. All these devices process and store data using binary codes only. So these are the devices are using binary codes. So these are the everyday in life. And last, conclusion. Binary codes are the basic language of digital computers. Therefore, binary codes are a fundamental concept in DLCO. They help computers store, process, and communicate information and transmission of data. So, this is the conclusion of the binary code. Thank you and bye.